Good morning. Okay, so today I'm going to go through the pre-quiz with you. So before we get started, make sure you grab a reference table. So I'm just grabbing mine. You always want to check your oxidation states with a reference table. Grab a piece of scrap paper so you can do your crisscrossing and crisscrossing reverse. And if you have to write out your algebraic expression, you are ready to do it. So let's get started here. So first question, in the compound NiBr3, Ni has an oxidation state, so a charge of what? And Br has a charge of what? Please place a plus in front of positive charges and a minus in front of negative charges, no spaces. So I'm going to look them each up on the periodic table first. So Ni can be a +2 or +3, and Br's negative choice is -1. So I'm going to write it right here, NiBr3. This 3 came from up here on nickel, and this 1 came from the Br. And I check it with the periodic table, and they both match. They both work out. So Ni has an oxidation state of +3. So I just crisscross reversed, and I got my +3 here and my -1 here, and I made sure it matched. All right, next one. In the compound CuCl2, so I'm going to do the same thing, CuCl2. That 2 came from up here. So copper +2. Chlorine, this is just a 1, so chlorine -1. And now I go check on the periodic table and make sure it could be right. Cu can be a +2, Cl is a -1. Perfect. So I put +2 and I put -1. Okay. In the compound H2CO3, hydrogen, carbon, oxygen. I got to figure out all 3 of them. So I'm going to actually write it down here where I have a little bit more room. H2CO3. So what do I know automatically? I know H is a +1. So can fill that right in. I know O is a -2. How do I know that? It's right here on the periodic table for me. So H at the beginning of a formula, positive, oxygen at the end, negative. It only has an option of -2, so I fill them in. I'm going to put an X for my carbon. I don't know what carbon is. I have 2 H's and each one is a +1. So 2 +1s plus I just have 1 X plus 3 -2s should all come out to 0. All of the charges times the number of atoms should come out to 0. So 2 plus X minus 6 equals 0. So 2 from -6 is -4. So X minus 4 equals 0. So X is equal to 4. So I go up here and I type in carbon has a state of +4 and oxygen -2. All right, next one. In the compound RuPO4, Ru has the state of, okay, so let's do it again. RuPO4. Ru, look it up. So Ru only has one possibility. It's always a +3. So I'm going to put +3 above that and mark that Ru is a +3. O I know is a -2. P is going to be my X. So I have 1 Ru, so that's 3, plus I just have 1 X, I just have 1 P, and then 4 times -2 is -8, should all come out to 0. So 3 from -8 is -5. So X is equal to +5. All right, next one. In the ion, so this time I can't set it equal to 0. This time I have to set it equal to the charge of the ion. So NO3 -1, NO3. All right, I'm going to put equals -1 because it doesn't equal 0. It's got a -1 charge on it. My N is my X, because remember, N's got that whole list of choices. My O is a -2. So X, 3 times 2 is 6. X minus 6 is equal to -1. So this would have to be a +5. And O would have to be a -2. All right. Next one. So these next ones all are oxidation and reduction reactions. So for question 6, what I have to do first, I look at this reaction, and the very first step is putting the oxidation state on top of each one. So oxygen is alone here, so I put a 0. Zn with S, I can look it up. Zn is always a +2, and S is negative is a -2. Now, if I hadn't looked that up, I maybe would have put 1 and 1. So that's why I got to have my periodic table here the whole time I'm taking the quiz. All right, S is alone, so that's 0. Zn, we said, is always a +2, and O is a -2. All right, now I want to see who is going up in charge and who is going down in charge. So who is being oxidized and who is being reduced. So S is going from a -2 up to 0. So this is my oxidized. And oxygen is going from a 0 down to a -2. So that is my reduced. Zinc has not changed. So I can cross zinc right out. Zinc is the spectator ion. So I want to say that S is oxidized and oxygen is reduced. There it is. All right, let's do another couple of those just for practice. So calcium and ammonia. Okay, so this is alone, so it's 0. This is alone, so it's 0. All right, NH3. So I look that up. I know H is going to be my +1. This 3 came from the N, so this is a -3. Now, NH3 is sort of a weird one. It's the only one that we're going to have that has the negative before the positive. And then calcium is a +2, always a +2 on the periodic table. This 2 came from here, which means this 3 came from here. So right away, I'm going to cross off the N because it's staying at -3. I want to see who goes up. Calcium goes up. It goes from a 0 to a +2. So that means it's being oxidized. Hydrogen is going from a +1 down to a 0. So that means it's being reduced. So put the charges on, identify who is going up, that's oxidized. Identify who's going down, that's reduced. So calcium is oxidized and hydrogen is reduced. There's my choice. And one more for practice. Oh, nope, that was it. 7 problems. Okay, so let me know if you have any questions, and I would be happy to go over any of them during office hours before you go and take the quiz.